Hello and welcome. In this video, we will be beginning with the topic of generics in Java. It is a prerequisite to watch wrapper classes and autoboxing unboxing before beginning generics. Okay, so please watch those videos first. So before beginning generics, let's see the idea behind it. So now my problem statement is I want to have maximum of two integers, between two integers the maximum value, between two doubles the maximum value, between two floats the maximum value. What I want to use a different class, a constructor of this class and a method of this class to get those values. So what I will do, I will create a non-gen ng, for example. This is my reference variable. Then what I will do, I will create an object using new non-gen. Okay, this is my object. Before that, what I have to do, I have to here declare two variables of integer type, int a comma b, a constructor for initializing the values of a comma b, int a comma int b, and this dot a equals to a and this dot b equals to b. Fine. And a method that returns an integer value, for example get int max. Okay, and it will return the maximum of these two values. Return math.max simply a comma b, and here I will pass my values, for example 5 and 6. So my output simply should be 6. ng dot get int max, ng dot get int max. So my output here should be 6. So let's see the output of this question. Okay, so the code will run and I will get my output. So the output here is 6, so no issue. Now let's see the internal working of this code. So this was my code. Here non-gen ng is a reference variable and new non-gen. So this will create an object. This will create an object of a class non-gen. Object of class non-gen. Every object contains the class's instance variables. So it will also contain a and b. It will also contain a and b, int a, int b. To initialize these variables, we have passed the value 5, 6 to the constructor, 5 to a and 6 to b. So my a value will be 5 and b value will be 6. And the getMax method simply will return me the maximum of these two, that is 6. Okay, and ng is a reference variable that is referencing this object of non-gen class. So I will get 6 as my answer. Next, what I want to do, the same thing, but this time for double. So new non-gen 5.5 and 6.6. Okay, 5.5 comma 6.6. Now as you can see, it shows me an error that these are double values but a constructor contains integer values, so it is expecting integer values. So I have to create a new constructor non-gen for double a comma double b. Fine. And to store these values, I want to create double variables, double c comma d. Okay, and here I will simply do c equals to a and d equals to b. No issue till here, and I will get my function, getMax function, that is now returning double value. So get double max. Okay, and then return math dot max c comma d. Fine. So now what I have the same thing for double. System.out .println, and I will get ng1 dot get double max. Okay, when I run it, I will simply have 6.6 as my answer. Now what is the problem? The problem is nothing. The problem is this is not generic. Every time if I want to now create for float, I have to create a variable of float, a constructor for float, and then a method for returning the maximum value of float. If I want for byte, then same things for byte. So this is not generalized. Okay, we want something generalized, that if I create variables, declare variables only one time, declare the constructor only one time, declare the getMax function only one time, and creating an object any number of times with any type of variable should do the trick. So this was the idea behind generics, generalized concepts. Before generics was introduced, Java has always provided us with the functionality of creating these generalized concepts. Okay, these generalized methods, these generalized classes or interfaces, Java has provided us with that functionality before generics also. Now we will see how Java does it before generics and what was the problem that Java has to introduce generics, though it contained the power to create generalized classes. So in a pre-generics code, for example, we have class non-gen. Here I am declaring an OB. OB is a reference variable of object class. OB is a reference variable of object class. So now why an object class? So object class is a parent class in Java, as we all know. So if I want to initialize this object by integer, I can do that because object class is a parent class of integer. Object class is also a parent class for float, for double, for char, for string. Okay, so therefore I am using object class here, the reference variable of object class. Next is we create a constructor for initializing it. Okay, again we have an object as of my type now, data type, that is the class name and its reference variable O. After that, what will happen? What I will do, I will copy the reference from this O to OB. Whenever a reference variable equals to a reference variable, the object is not copied but the reference is copied. The object is not copied but the reference is copied. The next thing is method to get the value. So it will return an object, therefore the return type is an object. Okay, get OB is a method, it will return a reference variable OB. Fine, this reference variable is an object reference variable, therefore the return type is object. Now in my main class, what will happen? In main function, I will create a non-gen object and store integer in it. A non-gen object and store an integer in it. So a non-gen IOB. Now IOB is a reference variable. IOB is nothing but a reference variable. Okay, so it is referencing a newly created object, which is of the class non-gen, Every object of the class contains its own copy of instance variables. Fine. So the instance variable in this case is OB. In this case, as we have seen, is nothing but OB. As you can see here, the instance variable of non-gen class is OB. Now in the constructor 88 is passed. In the constructor, what is passed? 88 is passed. It will come here, object O. Now O is also a reference variable. Okay, it will refer to the memory address where 88 is stored. Will store, and what it will do in the next step, OB equals to O. OB is also my reference variable. O is also my reference variable, and when I do OB equals to O, O will copy its reference to OB. Now OB will also point to 88. Fine. Next, what we will do here, integer v equals to integer. This is a typecasting. Okay, now integer is a wrapper class. I have told you this, that prerequisite of watching generics is wrapper classes. So integer is a wrapper class, and here is a reference variable iob.getObject. So it will go to the getObject function of non-gen class. And it will return me my value of OB. Fine. So now OB, as I have explained, is now pointing to the address where 88 is stored. Fine. So it will return me 88, and it will convert it into an integer. Therefore it will be stored in V, and I will have system.out.println V. So the output of here, it will be 88. So no issue. See, what I have done is I have created a generalized class in non-gen. Okay, a generalized class which will contain 88 is initialized with the value of an integer, whose object is initialized with the value of integer, as you can see here. Okay, now what I have to do, since this is generalized, what I will do, I will create a non-gen object for a string type. Now I can do that. I have told you in an example, for integer there is a different constructor, there are different variables, there are different methods. But here what I have done, since I am using an object class, object is a parent class, so I can set an integer there. I can also send a string there. So now I am sending a string. So a new, an object will be created. A new object, for example, a non-gen 2. This is a non-gen 1. A non-gen class, a second object is created because of this new. Okay, and my strOb is a reference variable that is referring to this object. Now what I will do in this, same, I have an OB. Similarly, I have an OB, the instance variable, because every object contains its own reference variable, correct? Now it will point to O, which will point to nothing but pre-generics code, where this string is stored, pre-generics code. So OB is indirectly pointing to pre-generics code. Fine, this is a reference variable, pre-generic code. Now when I get OB, that is strobe.getOb, what I will get, I will simply get pre-generics code. It will convert it to a string, it will store it to a string variable, and it will print it. So I will simply have here pre-generics code. Okay, the whole string. So no problem till here. So I have created before generics also, before generics concept was introduced, I have created a class which is capable of taking two different data types, that is integer and a string. So what was the need of generics? Now let's see what was the problem. Now problem occurs in this case. So we have already seen one problem. I will tell you what that was. So in this line, what is happening? IOB equals to STROBE. We have seen this type of line before. Just now, the line was OB equals to O. These are reference variables. So the object is not copied, but the reference is copied. So IOB is also a reference variable, as you can see here, and STROB is also a reference variable, as you can see here. So the reference will be copied. So the reference that was here will be copied to IOB. Now IOB will not point to this object, but the IOB will point to here. Okay, the non-gen2 object. Now from this, when I get OB, so it will return me an string. Instead of an integer, it will return me a string. Now I am trying to typecast the string into an integer. So here it will show me an error. It will show me an error. So this was the problem. Now let me explain you the problem in depth. What was the problem? The problem is, I have explained you what is the error, but during compilation, during when I am writing, the Java does not show me this error. During compilation, Java does not show me this error, and this error goes to the runtime. This error goes to runtime, and in runtime I will see this error. Now this was a very big issue because the whole code is written. Programmer doesn't know that it has an error because in compile time, because during compilation no error is shown. Okay, but in runtime the error is shown. So during testing we will see, oh, there is an error, but during compile time we will not know there is an error, and the cost of reducing this error will increase, and the cost of reducing this error or eliminating this error will increase drastically. Now why do you think Java does not show this error during compilation? Why? Just think, why do you think that Java does not show this error? It shows this error in runtime, but it should show the error in compile time also, but it does not. Now why do you think this is the case? This is because IOB is a reference type of non-gen class, and STROB is also a reference variable of non-gen class. So these both are actually of the same type, non-gen. They both are actually of the same type, non-gen. So if I have an integer I, int a and int b, and I do a equals to b, so this is not an error. Syntactically it is correct. Therefore the same line IOB equals to STROBE is syntactically correct. It is not wrong. Since it is syntactically correct, therefore Java will not show me an error, but this is semantically wrong. Therefore in runtime it will show me an error. Okay, so the error will be in this line, but the error is caused due to this line. Okay, the error is in this line during runtime, but the error is caused because I am writing this, and Java is unable to catch this in runtime because both are of non-gen objects. And the reason why this is happening, both are of non-gen, is because in non-gen I have an object class. I have an object class reference variable because only object class was capable before generics to store something integer and a string in the same code. Fine. Also, one more issue that we have seen here is, you have not realized it, but it is a problem. It is of manual casting. We have to cast the object into an integer. When we want its value to be used, we have to cast it into an integer. We have to cast it into a string, and this was the problem. It didn't show that my IOB contains a string now, but for me it did contain what you say, an integer. So I tried to cast it into an integer, and the error is shown in the runtime. I will just now show you in the IDE also what is the error. Okay, so this was the problem. So the problem occurred because non-gen is not a variable, okay, or an object in itself. It prevents the Java compiler from having any real knowledge. It prevents the Java compiler from having any real knowledge about the type of data actually stored in non-gen. Okay, so when I retrieve this IOB.get object, I do not know the type of data. I can only assume. Now because 88 was used, that is an integer, I used an integer. But when this line is executed, it is compiled correctly. So its reference changed from new gen 1 to new gen 2, and now we have a string in it. Therefore we have an error. Okay, so to solve all this type of problems, generics was introduced. All these problems, generics was introduced. So in pre-generic code, generalized classes, interface, and methods used object reference. So this was a very important point because they had to use object reference to make the class generalized. There was no other way but to use object references. Okay, so this approach had two problems: type safety and manual casting. So what is type safety? I have told you what is type safety. I have shown you that we do not know that we have an integer inside our reference variable or we have a string. It is pointing to an integer or a string or a float. We have no idea. Fine. And we have to do manual casting. In this approach, we had two problems, type safety and manual casting. I have explained you these 2 points, the what is manual casting and the type safety. I will also now code this on an ID, and there we will see what is the error is related to typecasting. Okay, so this is the code, this is the whole code. As you can see, we do not see any compile time error. Okay, so if there is an error in my code, for example, I do IOB plus plus, so now this is an error. I cannot use my reference variables as pointers. Okay, so I cannot manipulate them as I manipulate integers. These reference variables are different from pointers, keep that in mind. Okay, so see, it shown me an error just now. Okay, so this is compile time error. Fine, operator plus plus cannot be applied to this. Fine, but now it is not showing any type of error, no errors. When I run it, I get this error. The error is class cast exception. The error is class cast exception. This was the main problem before generics. Okay, we could use generalized classes, but there were so many instances when we get class cast exception. So to reduce this, generics concept was introduced. Okay, so let's see an introduction to generics. So with generics, we can define an algorithm once independently of any specific type of data. I just told you what is generics. We are not dependent on any type of data, we are independent of the type of data, and then apply that wide variety of data types without any additional effort. Generic means parameterized types. Parameterized types. Now what are these parameterized types? So parameterized types are important because they enable you to create classes, interfaces and methods in which this line is important. Type of data upon which they operate, is specified as a parameter. Type of data upon which they operate is specified as a parameter. So we all know what parameter is. When we call a function, we pass these parameters. Okay, now these parameters were actually my primitive data types, or in general any type of data type. Fine, we have a string, int, we pass these values, and these were parameters. Now what we will do, what we passed the variables of these data types, correct? But now what we will do, we will pass data types, not the variables of data types. So if my int a equals to 1, b equals to 2 integer, I passed a comma b, the variables. Okay, now what I will do, I will pass integer, int, not actually int but an integer. Okay, I will tell you what I meant by this point, not actually int, but I will pass my data type. So this is known as parameterized type. A class interface that operates on parameterized type is called generic. As in generic class or generic method. Generic means generalized, so it will become generalized. Whatever type we pass, if we pass integer, this class will work for integer. If we pass string, this class will work for string, the class will work for float, and we will not have class cast exception. We will be type safe. Also, we will not have to do manual casting because now auto boxing and unboxing will occur. Fine. So in the next video, what we will see these two examples again. What we have seen, that is, first one was get max, maximum for integer, double, float, and the second one was this object one. Okay, so we will see the generic code for these two pre-generic codes. Okay, today we have seen the pre-generic codes. In the next video we will see generic codes. I hope you understood what generics are. Okay, watch this video again. The generics is basically in one line used to generalize our Java programs. Now we can send integer, float, string, anything, and my single algorithm will work for all these types of different data types. Okay, we do not have to write our code again and again as we have did in the beginning of this video. Fine, thank you.